I've built a simple model here in Cyest modeler, just around the concept of trying to understand the performance variance in ounces on a mine. So what I've got here is a little model. I've built all the variables. There are the formulas you can see there as well in terms of how each of the different variables are done. I built a very simple little mine here, consisting of mine level, raise line with panels underneath each of those. I could actually look at the logic as well that I've built for this particular mine. It breaks it down into a value driver tree, so you can see quite nicely how ounces are broken and all of that. So what I've done is I've broken up into three main categories of reason. One is efficiency, meaning basically that you haven't achieved the advance you should have, so you didn't achieve the advances you should have. The other was, well, I might have achieved the ounces or the advance I should have, but I didn't actually mine in the right place. I might have mined off reef, I might have mined too much dilution. And the third reason is, well, I might have achieved the efficiencies, I might have achieved the mining discipline, and that means I mined in the right place, but maybe the ground just didn't have the ore in it that or the grade that we expected. So basically then I've driven or shown the value drivers underlying each of those. Meters squared is advance times face length, advance per blast, number of blasts. So all the underlying value drivers that actually drive it: blasting frequency, number of shifts drives number of blasts times face advance. So what I'm going to do now is I'm actually going to now show you how to use such a model for performance management. So I'm going to actually convert this model now into a little slideshow, and I'm just going to show you. So the first thing I've got here is, now I've got a little model here. So that's a show model I showed you. 4E ounces broken. It's got an efficiency, mining discipline, and resource categories, and under each of those I've broken down the actual drivers driving efficiency, the ones driving discipline, and the ones driving the resource. Resource really is the grade in the ground. Discipline is stope width and percentage dilution. Efficiency really is the production parameters. And I've got myself a little mine here, so I can drill down, and I could actually look at this value driver tree for Pacific panel to see the actual ounces, for example, generated. There was the budget, there was the actual. I could even run a what if scenario as well. So let's move on now and understand how we'd actually use this value driver tree to do some analysis, because remember, it's a model of the business. You change a variable, it'll change up. So first thing I'm going to do is I'm going to do what's called a reason for variance analysis. I'm going to do it at the overall mine. I want to understand this mine didn't perform. It was supposed to have done 5 million ounces, or sorry, 5,000 ounces, and it only did 2,900 ounces. The biggest thing is, well, what's the reason why? Well, interestingly, the grade in the ground was exactly as what was budgeted. 0% variance between budget and actual. Had no impact obviously on the ounces produced. But look at this, mining discipline, 12% reduction in mining discipline, which had an impact by itself of almost 590 ounces. All right, and then there's a 35% reduction in efficiency, which had an impact of almost 1,700 ounces by itself. Okay, now I could have looked at an individual panel and seen, well, look at this, interesting, at a panel level here, on this panel 1 in raise line 1 level 1, 3% improvement on discipline. Resource was 4% down, and the efficiency was 38% down. Alright, so I'm going to go back to my overall mine, because I want to start showing how you drill down into even more drivers that are actually driving these three main categories. What's important here is that its efficiency is the biggest one, interestingly. So now I've got the same mine. So overall, for this whole mine, these are the top drivers causing this variance between 5,000 ounces and 2,900 ounces. Look at this, advance per blast actually 4% up on this whole mine on average. Worst one, blasting frequency down 15%, had an impact of 750 ounces by itself. Number of shifts, 11% down. 545, face length down 7%. Now what's very important is the blue bar is the actual impact on ounces, not the variance in that variable. But you could go and look at, for example, you were maybe the MO belonging to a certain raise line. I could go and do the same analysis at a Pacific raise line, or I could even go and look at that analysis at a panel level. But now I want to do that reason for variance across the whole mine to find the biggest, the top reasons causing this variance and the location of those. So here it is. I've done that in reason for variance across the whole mine. Interestingly, here's the top reasons causing the variance. Panel 4's dilution was 44% up, which had an impact by itself. So this one panel for the one reason had a 340 ounces impact by itself. followed by panel 2, number of shifts, panel 5, blasting frequency. So straight away, if I was the general manager, or say this was a particular raise line, I could then go and highlight the top reasons why actually, or what I need to focus on, which is causing the variance in my 5,000 to 2,900 ounces target. And this is important because there's going to be variances across the whole mine. There's a lot of noises across the whole mine, and I really need to know what are my top reasons. Now, you would ideally want to now locate these panels geospatially. So what you'd really want to do is now show these panels geospatially, highlight which are the ones causing the biggest variance and the reason why. So integrate with the geospatial environment today should be very, very valuable, and we are doing some work on that. Alternatively, you could actually drill down and say, well, here's my budget, 5,000 ounces. There was my actual, 2,900. There's my 2 levels. Level 1, biggest reason for my variance between my budget and actual. Let's drill into level 1. Level raise line 1 and 2 also. This one was down 1,000 ounces. This one's down 975 ounces. Let me go down further. Panel 5 was down 530. Panel 4, 540. So immediately I've drilled down to a specific panel that had ounces variance. It doesn't give me the reason why. The reason why needs to actually be driven off this analysis. So I could actually just drill down to that specific raise line if I wanted to in panel. All right.